Hello everyone, welcome back to Smart Interviews YouTube channel. This is Aniket. Today we'll be solving problems from Codechef Starters 141, Division 3. Let's get started. So the question is nearly equal. The Hamming distance between two pairs of strings of equal length is defined to be the number of positions at which they contain different characters. So let's try to understand this with the help of an example. Let's take two strings of equal length, TH, E, R, E, and the other one is S, H, I, R, E. So how do we get the Hamming distance? We'll be checking the characters which are at the same position in both the strings. Okay, so here we'll be checking T and here we'll be checking S. Both of these are at the same position in both the strings, right? So both of these are not equal, right? So the Hamming distance as of now is 1. We'll check the next character now. H and H, both of them are same. So we'll continue with the next character. E and I, both of these are not same. So the Hamming distance is 2 now. Next, R and R. So we'll simply continue with the next character. E and E, both are same. So we can continue. So overall, the Hamming distance is 2 for this example, right? Now, in the input, you are given two strings. A string A of length n and you are also given string B of length m. Okay, also given m is less than or equals to n. You have to find the minimum Hamming distance between B and some contiguous substring of A that has length m. Okay, so let's try to understand what this contiguous substring mean. Let's take this example. Here, this is string A of length n, and the other one is string B of length m. Okay, A of length n and B of length m. Now to find the Hamming distance, we know that both of them should be equal length, but these both are not of equal length. So what we will do, let's say this is the example, this is over Z. So this is string A and this is string B. How do we find the minimum Hamming distance? In the question, in the problem, he said that we can take contiguous substring of A. So a substring is nothing but the continuous part of the string. Okay. So over here we can say a continuous substring is STOR, right? Or it can be STORM, or it can be OR, or it can be TOR. So these are the substrings of STORM. Okay. Now we cannot take SOR as a substring because these characters does not occur in a contiguous manner. Okay. So a substring is contiguous. Okay, I hope this is clear. Now how do we find the minimum Hamming distance? We know that to find the Hamming distance, the string A and B should be of equal length. But over here, the lengths are different. So what we will do, we'll take first substring of length m in string A. Okay. Now, for this substring, we will find the Hamming distance. Okay. So what is the Hamming distance for this substring? Both of these are not same. Both of these are not same and both of these are not same. So the Hamming distance is 3 as of now. Now after finding the Hamming distance for the first substring, we'll try to find the Hamming distance for the second substring. Okay, so we'll take this substring and compare with B. Now what is the Hamming distance over here? Hamming distance is again 3. Okay, so we'll continue with the next substring, which is ORM. Now what is the Hamming distance, guys? So if you observe, first characters are same in both. So we'll not add anything to the Hamming distance. Second character is also same. So we'll not add anything. Third character, they both are different. So the Hamming distance is 1. Hamming distance is 1. So this was for the first substring. Okay, this was for the second one. And this is for the third substring. Out of these three, 1 is the minimum. So we can say 1 is the answer for this example. Okay, 1 is the minimum, so this is the answer for this example. I hope this is clear to you. Now how do we code it up? Let's try to understand. Now if we consider the example, STORM, B is over Z. Okay, let's write indices over here, 0, 1, 2, 3, 4. For this 0, 1, 2. Now according to the constraints, the number of test cases are 100 at max. The length of A and B can go up till 100, right? So we cannot have more than 100 characters in the string A and B. So for this example, it is clear that we can really go with a brute force solution. Let's see what we can do. So what I'll do, to consider each substring, I'll fix this as I, and I'll take the first substring which is starting with I of length. Length is 3 because the length of B is 3. And to calculate the Hamming distance, we should ensure that the length of this substring is equal to the length of B. Okay, so we'll consider initially I is equals to 0. We'll start looping and we'll go up till I plus M. Okay, we can say less than I plus M. Okay, where M is the length of string B. And we can calculate the Hamming distance by comparing each character. After comparing the first substring, we can increment I so that I will become 1. So we'll be doing I plus plus. And we can compare the next substring. Similarly, lastly, when I is equals to 2, we can compare this last substring with B. Okay, and we'll consider minimum of all of them. Let's try to code this up. So everyone, we know that according to the input, the first line contains the number of test cases. So we'll read the number of test cases. We'll loop for t test cases. So we'll be looping for t test cases. In every test case, the first line contains n and m, which is nothing but the lengths of A and B. So we'll simply scan them. Next, the next line contains two strings, A and B. String A and string B. We can scan them. Now we want to find the minimum handling distance, right? Let's say I want to store the answer in a variable. With what value should I initialize? I can initialize with 100 because according to the constraints, the length of the string cannot be more than 100. So the answer cannot exceed 100 for sure. Or else I can also put this as M, right? I can also put this as M because the answer will not exceed the length of B, which is M. Next, let's calculate the Hamming distance for the first substring, then second, then third. We can do this with the help of a loop. So initially we have decided to write a for loop which will be initially starting with 0. So the first substring will be from 0 to M. Next, I 1 to M plus 1 and so on. So we can simply write a for loop for that. So I is equals to 0 and we can say I plus M less than or equals to M and then I plus plus. So basically we are trying to loop over, we are trying to find the all substrings and then with the help of looping we can simply calculate the Hamming distance. Now I want to store the Hamming distance. I leave that to a function called Hamming and let it find the Hamming distance for me. Okay. So what all parameters should be sent? I'll send this both the strings, then the starting of the substring of A, and then I can also send the length of B. Okay. Now, as I want to find the minimum Hamming distance, I can update my answer if the current Hamming distance is minimum. So I can take minimum of answer, comma, the value which I got. At last, I can simply print the answer followed by a new line. Now let's complete this Hamming function. It will send an integer. It will return an integer Hamming. In this, we are first sending a string A, then a string B, then this starting of the substring I, then we are also sending the length of string B. Now here, I'll try to store the answer which is nothing but the Hamming distance in a variable. Say int dist is equals to 0. Here I want to find the Hamming distance of B and substring of A which is starting at I. Now how do I do that? I can simply write a for loop which will be looping over the substring of A. So for int j starting from I, and how many characters we have to loop over? There are m characters in B, so we can simply say j is less than I plus m, so we'll be looping over m characters and then j plus plus. Now if the characters are not same, we can simply increase the distance by 1. So I can simply write a of j not equals to the character in B. If you observe one thing, the character will be starting in with the index 0 in B. So for that I'll simply write a variable int. Okay, I'll be checking with the 0th character initially, then first, and so on. If it is not equals, what can I do? I can simply write dist plus plus After that, I can simply increment the variable I and U. Okay. Now this will help me calculate the hammer distance and I can return it from here. I hope this is clear to you. Let's try to run this code. So what we got? Sample input 1412. Right, 1. Here it should be 4. Yeah, it's working fine. Let's try to submit this. And see, it works. So this is the code for this problem. Now let's look at one more problem. So the question is redundant array. Chef has an array A of n positive integers. Okay. So let's take the given example. 2, 4, 3, 2, 2. Okay. He can perform the following operations on the array as many times as he likes. Choose integers L and R such that L and R both lie between 1 and n and L is less than or equals to R. Choose a positive integer x and for every index I between L and R, set A of I is equals to x. Basically, he wants us to replace the element from L and R to x. Okay, if we choose our L is equals to, let's say 2, over here the index can go from 1 to n. So he has taken 1 based indexing. 1, 2, 3, 4, 5. So L is equals to 2 and R is equals to, let's say 4. And we can also choose a value for x. And we can replace all the elements from 2 to 4 with the value x. Let's say I want to take x is equals to 5. Let's say I want to take x is equals to 5. And I can replace the values with 5. Now this operation will cost us r minus l plus 1 into x. Okay. So this operation costed us here, this is r minus l plus 1 is nothing but 4 minus 2 plus 1, which is 3 into x. So into 5, 15, right? So this operation has costed us 15. We have to find the minimum cost of making all the elements of the array equal, right? We have to find the minimum cost of making all the elements of the array equal. So over here, if you observe, the cost of changing 3 elements is 3 into 5, nothing but 15. Okay. L minus R plus 1 is nothing but the length of the subarray, which is nothing but the length of, which is nothing but the number of elements in the subarray. So in this array, in this subarray, we have 3 elements. So R minus L plus 1 gives 3. We can also perform the same operation by taking this subarray first and then this subarray first. Okay. So it's nothing but changing the individual elements, not choosing these two, and then these two will also incur the same cost because changing one element will cost us x. So let's break down this problem. instead of choosing a subarray like this, we'll simply choose individual elements, which will be easier for us, right? So we'll be choosing individual elements, which will also incur the same cost. Now, we have to find the minimum cost, right? So if we change the elements to 5, we know that all of them should be equal to 5 at last. So the cost incurred for all the elements in the array will be 5 into 15. 5 into 5, nothing but 25. Okay, 5 into 5, 25. But what if I want to make it, let's say 3? So I'll change all the elements to 3. Now what is the cost? 3 into 5, which will give 15. But if you observe one thing, here the value at index 3 is already 3, right? So we don't have to change this. So we can say the cost is 3 into 4, which is nothing but 12. This is the cost of changing all the elements to 3. What if I want to change all the elements to 1? So over here, none of these elements are equals to 1, so I have to simply change them to 1. So 1 into 5 gives 5. So till now, this is the best possible answer that we got. Can there be a better answer? Can there be a cost which is less than 5? Yes, of course, we have. So what if I want to change all the elements to 2? This is already 2. I want to make it as 2, make this as 2. So I've changed 2 elements, so the cost is 2 into 2, nothing but 4. Okay. So this is the best possible answer that we got till now. Can there be a better answer? For this example, there is no better answer, so the answer is 4. Now, how do we get the minimum possible cost? Initially, when I say I want to change it to 5, because there are no elements with value 5, I have to change all of them, and that costed me 5 into 5, nothing but 25. But when I chose to change all of them to 1, so if all of these are changed to 1, I got answer as 5. Okay. But when I chose to make them as 2, I got the answer as 4. Right. So I just had to change these 2 elements. Now how did I get the cost as 4? Number of elements that I have changed. Right. How do I get the number of elements that has to be changed? Can I say the total number of elements, which is n, minus the frequency of 2? The frequency of 2 is 3 in this example. Other than these 3 elements, I have to change all of them, right? So I can say n minus 3, and the cost of each change is 2. So if we generalize this, the cost of changing a particular value x is n minus frequency of x into the value x itself. Okay, the value x itself. So there are 2 things over here. If the frequency is more, the overall value will be less, right? If the frequency is more, the overall value will be less. And one more thing, Over here, if I want to change the value to all ones, the value of x is less, right? So the value of x is less over here, which I have chosen as 1. And that, for this example, gave a minimum cost of 5. So which one to go with, right? Either I should minimize x or I should maximize the frequency. So we cannot decide that, right? So we can simply try to find out every possible case, right? For every element, we can try to find out the frequency, and then we can apply this formula to get the cost. Because if you consider the example, let's say we have 1000, 1000 and 1000, and let's say I have 2. The frequency of 1000 is 2. The frequency of 1000 is 3. If I make this to 1000, the overall cost will be 1000, right? But instead, if I make them equal to 2, the overall cost will be 2 into 3, nothing but 6. 6 is better than the value 1000. Now, there is one more case where we can simply replace the values by 1, right? We can simply replace the values by 1, which will give us the cost as 4. And this is the minimum for this case. Okay. Now, if you observe, for any given example, what if you can simply override the values of the elements by 1? So if I override these values as 1, the maximum value will be n itself. So we can surely say the answer will never exceed n, which is nothing but the length of the array. So this is important observation that you have to keep. The minimum cost is always less than or is equals to n. Because if we simply override the values and change them to 1, we'll get a cost of n, right? That means the minimum cost cannot be greater than n. So this is one observation that we can do. And over here, for any example, like this example, what we can do, we can simply find the frequency for a particular element, and we can apply the formula something like this: n minus frequency into the value x. Okay. So over here, I can say array of I, because array of I is the element in the array. And this frequency is the nothing but the frequency of array of I. And that is how I can find out the answer. Now, how do I find frequency of the elements? If you look at the constraints, the value of A can at max go to 10 power 5. 2 into 10 power 5, right? So we can simply take a list of 2 into 10 power 5 and we can keep track of the frequency. Or there is one more way of doing that, is to use a hash map. Okay. If you use a hash map, let's say this is a hash map. First I got 2. The first element is 2. So I'll simply insert 2 and the value place will have the frequency. Next 4. So I'll store 4 comma 1. Next 3 comes up. So 3 comma 1. Next 2 comes up. So I'll simply increment the frequency. So it will become 2 comma 2. Next 2 comes up. So the frequency will become 2 comma 3. Okay. So this is how we can get the frequency. And with this formula, we can simply find out the cost and we can take minimum of all the cost. I hope this is clear too. Let's try to code this up. So let's look at the code for redundant array. The first line of input contains the number of test cases. So we'll make the test cases. will loop for t number of test cases. And in every test case, we are having the size of the array, which is n. We'll scan n, and the next line contains the array elements. Okay, so I'll declare an array of size n. And also one thing, to keep track of the frequencies, we can use a hash map, an unordered map. Of type int, int. Now we can simply scan the elements of the array. Int temp is equals to int temp, say in temp. Here array of I is equals to temp. And we can also do map of temp plus plus. Okay. So when there is no element of value temp, it will store by default. Let's say the value is 2. The default value will be 1. If there is a value, it will increment by 1. Okay. So this is how it works. Now let's store the answer, which is the minimum cost. Now, as we know, the minimum cost cannot be greater than n, right? So I'll simply write n over here, and let's try to find out the answer. Now I'll loop over the elements of the array. Now what was the formula, guys? The formula was something like this: n minus frequency of the current element into array of I. So this was the formula, right? Now the current element is array of I. Now how do we get the frequency? Frequency is nothing but map of array of I. So this will give us the frequency. And what if we choose the current element as x? We'll get something like n minus frequency into array of I. I'll change this to long to avoid overflow, if any. Now I want to get the minimum cost. If I choose the current element, I'll get this cost. Out of all the cost, I want to get the minimum. So my answer will be storing minimum of answer comma the current value. Okay. At last I can simply print the answer followed by new line. So let's try to run the code. It is giving 405. So for this example, it's 4. Yeah, as there are no different elements, all of them are same. So for this example, it's 0. And for this example, it's showing 5. Let's try to submit and check. And see, it's working. So this is a code for the redundant array problem. I hope this is clear. So the question is amphibian escape. Chef is building a robot shop which he would like to be able to climb out of the well quickly. Okay, so the chef is building a robot shop and there is also a well, right? So let's draw a well. Let's say this is the well. The well has a height of h units. Okay, let's say h is the height of the well. Initially, the frog is placed at the bottom of the well. So frog is somewhere here at the bottom. Let A denote the jumping power of the frog and B denote the slipperiness. So we have A as the jumping power and B as the slipperiness. The frog is initially at position 0. So this position is nothing but 0. So every second two things happen. There are two steps happen in order. First, the frog will jump A units upward. So it will jump A units up. So that will increase the value of x by A. So x becomes A if it is initially at 0. If it is at this position, it will jump by x, right? So x becomes 2, something like that. If the frog reaches the height h or greater than that, it is considered to have climbed out of the well. So if it has reached this position, this height, or greater than that, it will climb out of the well. Next, if it is still within the well, it will then slip b units downward. Okay, that is x will reduce by b. So over here, what is telling is, so if it has jumped a units up, if it hasn't reached the height of the well, it will slip down b units. So initially x was a, let's say if it was a, it will slip down to b. So the effective will be a minus b. Now there is one more thing which is mentioned over here is that if b is more than a, it cannot go below x is equals to 0. So we always have to take x is equals to max of 0 comma x minus b. I hope this is clear to you. Now chef hasn't decided on the jumping power of the robot frog and also doesn't know the slipperiness of the well. You are given three integers n, k and h. N, k and h. So what you have to do? Count the number of pairs a and b such that a is less than or is equals to n and b is less than or is equals to m. Okay. If the frog has jumping power a and slipperiness b, and what does h denote? H denote the height of the well. So the frog can escape the well within k seconds. Okay, so we have to find the number of pairs AB such that the frog can escape the well of height h within k seconds. Let's try to understand this with the help of an example. Let's consider this example. Let's say here n, k and h, n is equals to 5, k is equals to 4, h is equals to 4. So the height of the well is 4. What is k? K is nothing but time given to us. So k seconds. And n is nothing but the maximum value up till which a and b can range. Okay. So it's given that 1 less than or is equals to a less than or is equals to n, and 1 less than or is equals to b less than or is equals to n. So this is what is given. Now we have to find the number of pairs such that the frog can climb a height well of height 4 in 4 seconds. Okay. If you observe, let's consider a pair of A and B. Okay. What is, let's say A is equals to some and b is equals to, let's say b is someone. Okay, so what will happen after first second? It will jump one step, two steps, so it will come to a height of 2, but again it will slip by b number of steps, so it will come down again. So the resultant height will be 1. Okay, because it has jumped 2 steps and it slipped down 1 step. 2 minus 1 is nothing but 1. So that is happening after the first second. So we know that after 1 second it is somewhere here at a height of 1. X is equals to 1. After second what will happen? After 2 seconds it will go up till 2 units higher and it will come down 1 unit down. So effectively it will again climb 1 more step. So x is equals to 2. So the height is 2 over here. Now again, what will happen? It will climb 2 steps. Now the height here became 4. After that, should it come back and slip 1 more step? Should it come back and slip 1 step? No, right? Because it has already reached the top of the well and it can climb up. Okay. So we can say in the third second, it is able to climb the well with A as the jumping power and B as the slipperiness. Okay, is this clear? Now, is this a valid pair? Yes, it is a valid pair because we have overall taken 3 seconds. Right, we have taken 3 seconds, which is less than k. So k is the time limit given to us, and we are able to, the frog is able to climb in 3 seconds itself. So it's a valid pair. The pair is nothing but 2, 1. In this pair, you have to find all the valid pairs. Okay. So for the test case 2, we have come up with 2, 1 as a valid pair. So this is a valid pair. These 2 are the valid pairs and so on. All these are valid pairs. And we have to print the number of valid pairs. So the answer over here is 13. I hope this is clear to you. Now for the first example, where our n is equals to 1, k is equals to 5, and h is equals to 5. So can we jump out of the well? So we know that a is nothing but 1 less than a less than or equals to n, and b is nothing but 1 less than b less than or equals to n. So this is the range of b as well. So there is only one possibility that a can be 1 and b can be 1. So 1, 1 will be the pair. If it is moving 1 step ahead and coming down 1 step, the overall moment is 0. There is no moment, right? So it can never climb the well. So there is no pair possible. So the answer is 0 for this example. I hope this is clear to you. Now how do we come up with the logic for this one? Let's try to understand. Let's say we have a well of height h. I'm taking small h for convenience. So a well of height h, let's say A is the jumping power, B is the slipping. Okay, B is the slipperiness. So over here, let's say it goes up by A steps, come down by B, A steps, and then come down by B, and then lastly it can climb up with A steps. Okay, so we know that this will happen in 1 second of time, right? So we can say this last step will take 1 second. Okay, this last step will take 1 second, and we know the height is h over here. Now if this length is less than A, will it be able to climb? Yes, obviously, because the jumping power is A, it will simply cross. Now, if the height over here is exactly A, will it be able to climb? Yes, exactly, it will be able to climb. Now, if this is greater than A, will it be able to climb? No, right? It will take more than 1 second to climb over from this position. So what we can do from here, we can simply leave off this A units, which will only take 1 second of time, and for the other units, we can simply calculate the time taken. Okay, so effectively, we have to calculate the time taken to reach H minus A unit, because the last A steps it can jump in 1 second. Now, let's say we have a well of height 7. Okay, so there is a well of height 7, and let's say we have 2 as the jumping power, 1 as the slipperiness. In 1 second, it will reach a height of 1. Okay, because it will go 2 steps up and it will come down 1 step. After second, it will come here, third second, fourth second, fifth second, right? After 5 seconds, it will come to a height of 5. In the next second, it will simply jump 1 step up and climb up, right? So this is the 1 second that we are talking about. Now we have to find out the time taken for these many steps. We know that the effective step is A minus B, because it is going A steps up and coming down by B steps. And for climbing this 5 steps, a height of 5, we can simply calculate by 5 by 2 minus 1, which is 5 by 1, and it is nothing but 5. So it is taking 5 steps, 5 seconds, right? So to get to a height of H minus A, we can say it is taking A minus B seconds, right? And we'll simply add 1 to it, because the last step, in the last step, it will just climb up over the well. So this will get the number of seconds for this part, and the top part, which is less than or equals to A, we can say A, which will take 1 second. Okay. Now when can we say it is a valid pair? If it is taking less than or equals to K seconds, right? We are also given the time limit, right? Now if this time plus 1 is less than or equals to K, then we can say that A comma B is a valid pair. Then we can say the A comma B is a valid pair. And over here also, make sure that we will take the seal of this. Okay, we are taking the seal of this, because let's say if the time taken to jump this distance is something like 6.8, okay, we can simply consider that as 7 seconds, right? And above that, it will take 1 second to jump. Okay, so in 1 second, all these things are happening, right? So we can simply take the seal of it, which is 7 seconds. Now we have to calculate the number of valid pairs of A and B, which will satisfy this condition. Okay, which will satisfy this condition. Now how do we do that? How do we do that? Let's try to understand with the help of an example. Let's see here itself. So let's say we are given the values of N, K, and H. We want to find the number of pairs A and B, which will be the jumping power and slipperiness of the jumping power of the frog and slipperiness of the well, and this will help us to climb the well within k seconds. We know we can simply find out every possible pair, right? We can simply find out every possible pair, but there is an issue with that. According to the constraints, we know that n can go up till 2 into 10 power 5, right? So if we simply find out every possible pair, that will be an operation of big of n square. That will be a big of n square complexity. Okay, which will be more than 10 power 10 iterations, and that will give a TLE. So I have to optimize this. Instead of finding every possible pair, I'll try to find out the values for A first. Okay. Now let's say n is equals to 10. The values of A can range from 1 and can go up till 10. The values of B also can start from 1 and go up till 10. But if you observe one thing, let's say a pair of A is equals to 10 and B is equals to 5 is a valid pair. Can I say a pair of 10, 3 is a valid or not? Can I say this is a valid? Yes, exactly I can say, because the effective distance over here is 5 and the effective distance over here is 7. So it will surely be able to climb the well in lesser time. Okay, so that is obviously a valid pair. So any value which is less than 5 will be a valid pair. But can I say 10, 8 is a valid pair? No, I cannot say. I have to check first, right? With this knowledge that 10 power 5 is a valid pair, I cannot say 10, 8 will be a valid pair or not. It may or may not be a valid pair. So what we can do, we can simply find the max value of B, which satisfies this condition, right? If 10, 6 is a valid pair and B is the maximum value, 6 is the maximum value of B. So we can say all the pairs from 10, 1 to 10, 6 are valid. So we can simply count all these pairs, which are 6 pairs, for a number A, right? So first we are fixing A. We are trying to find the maximum value of B which satisfies the condition. Okay. So it's nothing but we can simply find out the ceil of B. Ceil of B such that it satisfies the condition. We know to find a ceil, what we can do? We can simply use a binary search, and one binary search will take log n time. Okay, log n base to time. Okay, in the worst case, and we are doing that for every value of A. So we can say n log n. N log n will be the time complexity, and under the constraints, this solution will get accepted. Okay. So with this knowledge, let's try to write the code. So let's look at the code for amphibian escape. First line of input contains a number of test cases. We'll loop over the test cases. Then in every test case, we'll have N, K, and H. K is equals to S dot next state, and H Now, let's say we want to store the answer in a variable. Initially it is 0. That means we have not found any pairs. We can simply find that with the help of the loop. So I'll be fixing the value for a. I will go until n and then I plus plus. So basically we're fixing the value for a. So I'll change this as a, which makes more sense. Okay. Now there are few scenarios. Let's say my height is equals to 5. My height is equals to 5. And let's say my jumping power is 7. It is for sure that I can jump out of the well in the first second itself. And whatever be the value of B, it will not matter, right? Whatever be the value of B, it will not matter. So I can say with A is equals to 7, I have 7 values of B, right? So when A is greater than or is equals to the height, I can say my answer is equals to answer plus number of values of B, so which is n, else I can simply find out the seal of B. For that, as we have discussed, we can do a binary search. Now I fix the value for A. I have to find the maximum value that B can get. It can get a value of A minus 1, because if A and B are same, there will be no progress and we cannot climb out of the well. The frog cannot climb out of the well. And for the same reason, B cannot be greater than A, right? And other thing, we can simply send the height of the well and K. After this, we can simply print our answer. Okay, let's try to complete this binary search function. Let's say it will send an integer bs, and then the parameters are a, the maximum value that b can take, which is I can say as high, because in binary search we'll have low and high, then we'll have height of the well, and then lastly k seconds. Okay, I can initialize my low is equals to 1, because that is the minimum value b can take. I'll store my answer in a variable, say max. I can simply run a while loop. Low less than is equals to high. Implied low plus high by 2. Now, if possible, if a particular value for b, which is nothing but if it is possible, we know that b is equals to mid. If it is possible, we have to find a better value, which will be even more than the current mid, right? So we are trying to find the seal of b. How do we check if it is possible or not? We can simply make use of the formula that we have written. H minus a is equals to by a minus b, which is nothing but mid. Okay, now I have to take seal of this value, and we know it will take an extra second for the last step, and this should be less than or equals to k. Okay, now because these are the integers, we will lose out the precision. So I'll simply write a double over here, and I'll simply update my answer, and I'll try to search for a better answer by updating my loop. And in the else part, I can simply write high is equals to mid minus 1. At last, I can simply return the maximum value that b can take, which is stored in the max variable. So I hope this code is clear to you. NKH, everything looks fine. We'll just try to run and check. So it's given, okay. So this is the output that we got, which is same as the expected output. Let's try to submit and see it works. So guys, this is the code for amphibian escape problem. This is binary search. I hope the video was informative. If so, do share with your friends, and for more such informative content, like, share and subscribe to our Smart Interviews YouTube channel. Until the next video, this is Aniket Deshmukh signing off.